Okay, so we talk about block cipher. This is a symmetric key encryption primitives, block cipher and stream cipher. Please go to the slide, please. So, block cipher and stream cipher are two symmetric key primitives. So, in symmetric key there are two parties, Alice and Bob. They have a shared with the common key k, the secret key k, and they want to communicate with each other. So, Alice is having the message. So, Alice is encrypting the message using this k and sending over the public channel, and this channel is very much captured by the adversary or the third party. So, this is the ciphertext after the encryption, and this ciphertext is sending to the BOF, the receiver, and receiver is having the same key. So, receiver will decrypt the ciphertext using the same key and get the message. So, this is the typical setup of a symmetric key encryption, and block cipher is a primitive of symmetric key encryption. In block cipher, we have basically a black box. So, it takes the input, say plain text, and plain text say n bit, we have n bit plain text, and it will generate a n bit ciphertext, and it is taking a key which is say k bit, secret key which is shared between Alice and Bob, and inside it if it is R round block cipher. So, this is block cipher, this function. So, basically block cipher is a function, it is an encryption function. It has two input, one is plain text, another one is key, and it is giving us the ciphertext. Okay. So, plain text is n bit, ciphertext will be also n bit, and the key is the k bit, k binary bit. So, if we consider the R bit R round block cipher, R round block cipher. So, it is basically having R round inside. So, this is the first round F1. So, which is taking input as a plain text, which is denoted by x or x0, and which is having another input which is called round key. This is typically a first round key, and then in the second round, which is the input after this first round, this is we can denote by x1, which is basically f1 of x0 comma k1, and which is a input of this second round function. And for second round function, we have another input which is the second round key k2, and it will give us the output x2, which is basically f2 x1 k2. So, like this we continue. So, dot dot dot. So, this is the R f r minus 1, and this is f r. Okay. So, for f r minus 1 we need another. So, one input is coming from the output of the previous round, and another input is k r minus 1, and so this is basically x r minus 1. Now, this is basically x r minus 2, this is basically x r minus 1, and so this is k r rth round key, and this is basically called y, which is the ciphertext, which is basically f r of f r minus 1 comma k r. Okay. So, this is the plain text, and these round keys are basically the inputs of each rounds respectively. So, where from we will get these round keys? This round keys is coming from a public algorithm which is called key scheduling algorithm. There is a public function, public algorithm which is called key scheduling algorithm, which is taking input as a secret key k, and it should able to generate the round keys k1, k2, how many rounds we want, dot 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 dot. So, this key scheduling algorithm is taking the secret key which is shared between Alice and Bob and giving us the round keys, okay, as many round we need. So, this is typically R round block cipher. R round n bit. So, plain text is n bit, ciphertext this is y, this is the last round output, this is y. So, this is also n bit. So, this function is called. So, this is taking input plain text and another input is the key, and inside we have a key scheduling algorithm which is generating the round key as much we need. Then after this round, so first round input is plain text, then it is taking this round key, it is outputting the intermediate value x1, then it is the input for second round function, then third round function, so on, and each time for each round function we need another input which is called round key, and which is coming from the key scheduling algorithm of this which is public function, which is algorithm which give us the round keys from the secret key. Okay. So, this is a typical R round block cipher, n bit block cipher. N bit block cipher means plain text and ciphertext size is n. Okay. So, there are some example of block cipher like SPN. We will talk about SPN now. It is substitution permutation cipher. Substitution permutation. It is called substitution permutation cipher, substitution permutation network, SPN, and we have these are some example of block cipher. Example of block cipher. Okay, another one is DES, data encryption standard. It is a 64-bit block cipher. So, n is 64. So, n is 64 and R is 16. So, it is 16 round block cipher. So, 16 round block cipher. So, we have 16 round function inside DES. We will talk about those details, and the key size is 56 bit, effective key size k is 56 bits for DES. And another example is AES, advanced encryption standard, which is basically Rindle. So, this is also a block cipher. It is 128 bit block cipher, that means n is 128. So, plain text and ciphertext size is 128 bit, and R is, it has different version. R the round functions are either it is 10 round, 12 round, 14 round, depending on the size of the key. So, if the key is 128, then it is 10 round, 192, then it is 12 round, 256, then it is 14 round. Anyway, we will talk about details of this block cipher. So, basically if we take any block cipher, its structure, its general structure is basically same as this. So, if it is R round, we have R many round functions, and we have input size is the size of the plain text. If it is n bit, so n is the input of the plain text, and we will get the n bit ciphertext, and for each round we need to get the round keys, and that will be coming from a what is called key scheduling algorithm. Okay. Now, go to the slide please. Okay. So, this is a typical example of a R round block cipher. So, here we are assuming all the round functions are same, which is f. So, f1, f2 all are same functions. So, we have a plain text x, which is we denote by x0. Then we apply f with the round keys k1, and we got x1. Then we apply that value we apply on another f2, which is again f. We are assuming all round functions are similar. So, x2, in this way we continue. So, finally, we got the ciphertext, which is basically xr, which is the output of the rth round function, and for that rth round function we need a round key here, rth round key, and these round keys are coming from the secret key k, which is shared between Alice and Bob, and with the we are applying the key scheduling algorithm on this. Now, the question is how to decrypt such a block cipher. So, for decryption we have to assume f should be injective, it should be invertible, otherwise we cannot decrypt this block cipher. So, for decryption we have y, from y we need to get back the message x. So, we just reverse the process. So, we start from the y here. So, y is the ciphertext now. This is the encryption. This is encryption of a block cipher, and for decryption what we do? So, for decryption our input is this y. So, y is the input. So, we apply we have to go back here. So, for that we have to apply fr inverse with the round key kr, and then fr minus 1 inverse with the round key krms. So, that is why this round function should be invertible. We should able to invert this round function, it is injective function. So, dot 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 like this. So, we have this is f1 inverse and this is k1. So, we should get x0 or the x basically the plain text. So, this is the ciphertext. So, again this is doing by the receiver Bob. Alice and Bob sharing the common key k. So, Alice is encrypting this. So, Alice has a plain text m which is basically n bits. So, what Alice will do? Alice will apply this block cipher on this n bit and get the ciphertext y, and Alice will send this y to Bob. So, upon receiving the ciphertext, Bob has the secret key k. So, Bob will this function is public, everybody knows this key scheduling algorithm. Only thing the secret is the secret key k. K is not known to other party other than Alice and Bob. So, this is decryption. This is Bob is doing. Okay, decryption CRY. Okay. So, Bob is using the same key scheduling algorithm and getting the round keys and applying this on the respective inverse round function and get the plain text. So, this is the typical decryption of a block cipher. Okay. So, now we will discuss the block cipher SPN, which is substitution-permutation network. Okay. So, let us talk about an example of a block cipher. So, this is substitution and permutation network. This is the first example we will study for example as a block cipher. Okay, this is in short it is called SPN. So, it has some substitution function and the permutation function. Okay. So, for this we have this plain text. So, here plain texts are x1, x2 like x lm bit. So, size of the plain text is ln bit. So, n is equal to L into m. Okay, this is the size of the plain text. So, what we are doing? We are just dividing the plain text into L bit each. So, this is dot 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 xl. So, this is basically x1, x2. So, x m. If we break this plain text into L bit each. So, this is first L bit, then second L bit like this. We are blocking this. Then we denote this first L bit as x1, second L bit as x subscript 2 like this. Okay. Now, suppose we have a S box which is a function which is taking L bit input dot dot dot, this is L bits, and which is taking a dot 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 L bit output. So, basically S is a function which is 0 1 to L to 0 1 to L. So, we denote this by say pi of this. Okay. And suppose we have a permutation which is basically permutation on this bits of LM to 1 to LM. Okay. So, we have these two. So, this is substitution permutation network. So, this is the substitution function. We have a substitution function S which is taking the L bit input and giving us the L bit output. So, this is basically a function L bit to L bit function. We will come to an example, and we have a permutation which is basically suppling the bits. So, permutation from 1 to xn. Okay. So, now, encryption for encryption what we will do? We will just first apply S on this, S box on this like this, and this is the substitution operation, and before that we need to apply the round key, add round key. So, suppose we have round keys say k1, k2, say we have say 5 round keys. So, what we do before this, we just add the round keys. So, bitwise adding. So, this is also L bit. So, small k1, small k2. So, this is k1 like this, k lm like this. So, we just bitwise XOR with this. So, this is we can just use with this k1, k2, 1 like this. So, bitwise XOR, this is the round key operation we are doing. Then after that we are making into the blocks. So, maybe this is some y1, y2 like this. So, then we apply the S box on it, again it is L bit, we apply S box on it, again this is L bit, all are L bit. So, after this, so we have again LM bit, and this LM bit will apply the permutation. We have pi of p, which is just basically suppling the bits. Maybe this bit is going there, this bit is going here like this. Okay. So, this is the permutation we will do. So, this is a typical one round of SPN. So, now let us this is, can you go to the slide please. So, this is a diagram which we have taken from the Stinson book. So, this is an example where our L m are 4. So, suppose we have 16 bit n is equal to 16 bit number, and this 16 bit we are dividing into, so say x1, x2, x3, x4 like this, x16. So, x5, x6 like this. So, what we are doing? We are breaking into 4 bit blocks. So, how many blocks we have? 1, 2, 3, 4. So, x15, x16, x14, x13. This is the last block. So, each is a single bit. Okay, can you go to the slide, please? Okay, so here this is our plain text x. This is a 16 bit number. So, this we are blocking into 4 bit each, and then we have a round key k1, which is again a 16 bit number. So, what we are doing? We are just doing the XOR with this x and this k1 bits. So, both are 16 bit. We will do the bitwise XORing. Okay. Then after that, we are getting again a 16 bit number, this u1, and this 16 bit number again we are breaking into 4 bit blocks. So, for this 4 bit, this 4 bit like this, and then again we apply the S box. We have S box pi of s, which we will define, which is taking a 4 bit input and 4 bit output. So, again this is 16 bit, and this 16 bit we are applying that permutation. So, it is a permutation from 1 to 16. So, it is just suppling the position of the bits. So, this is a typical one round SPN. So, this is the first round. So, similarly, in the second round we will do the x2, and then we are again we block it into 4 bit blocks, and then again we will apply the S box, and then again we will do the random permutation on it. That permutation we will define. So, this way we continue. So, this is a 4 round block cipher, but in the last round we will have extra we will have a, so we will have a extra round, add round key here. This is the XORing, this is the extra operation, otherwise this is a 4 round block cipher. Okay. So, now we will talk about the S box. So, for this we need to have a S box, which is basically taking a 4 bit input, 4 bit output. Okay. So, 4 bit we can represent binary bit. So, 4 bit number can be represented as hexadecimal number. So, yeah. So, this is the S box. So, this is given in input is 4 bit. So, any 4 bit number is can be represented in hex number. So, this is say 7. 7 is basically what? 7 is 1 0 sorry 0 1 1 1. This is basically 4 to 7. So, that means 0 1 1 0. So, if the input is 7, can you go to the slide, please? Input is 7, slide please. So, if the input is 7, here table is showing that output will be 8. So, the 8 means in hex it is 8. So, 8 means we have 1 0 0 0. So, this is the, so if the input is this, output is this. So, this is a function form. Zero 1. So, 4 bit to 4 bit function, which can be very well given in the in this table. So, it is a hex table. So, in this table we just represent the in the hexadecimal form, because 4 bit can be in hex form, and this permutation is also given. So, this is the this is 16 bit, n is equal to 16. So, 1 to 16. So, this is the permutation, that means x1 is going to 1, and this x2 position, x5 is coming here, x9 is coming here, x13 is coming here, x2 is going here. So, this is the suppling of the bits. Okay. So, this is the SPN network. Now, we will take some example how it is working. and before that we just discussed the key scheduling algorithm for this. So, in this case we need to have how many keys? We need to have 5 keys, K1, K2, K5, and suppose this is the secret key shared between Alice and Bob. Now, from here this key scheduling algorithm is very straightforward, very simple for this cipher. What it is doing in the key scheduling algorithm, we are just taking K1 as a this first 4 hex bits. So, this one, this one, this one. So, this is the K1, and the K2 will be we do not consider the first one, from the second one 4 hex bits. So, this is basically this, and K3 will be similarly this, K4 like this. So, this is the simple key scheduling algorithm from this round key, from this secret key. This is the secret key shared between Alice and Bob, and this is the way how we generate the round keys. We need to have 5 round keys. Okay. And here is an example. If we execute the SPN, so this is the, suppose our plain text is this, which is again a 16 bit. So, what we are doing? We are just taking this plain text, and then we are just having the first round key K1, and we are doing bitwise XORing with this. So, 0 0 0 0 0 0 and 0 1 sorry 1 1 1 1 is 0, there is no carry. So, this is just a bitwise XORing, and then we are doing this bitwise XORing with this round key K1, and we are getting this output, and this output will apply the S box. We have a S box which is taking the 4 bit to 4 bit. So, this is giving us the S box output. So, we got this V1, and after getting V1 we are shuffling the bit position. So, we are applying the permutation P, which is basically changing the position of this bit position, and we are getting this. So, this is a typical first round of a SPN. Okay. And then we will go for the further round, there are 4 rounds. Then we go for the next round, which is again K2, then XOR with K2, then like this. So, if you continue like this, we will just end with this the ciphertext Y, and this is the Y. Now, question is how we decrypt it. So, this is the encryption, this is Alice is doing. Now, how to decrypt it? Decryption of SPN. Okay, so, for decryption Y is given, which is again a 16 bit. What we do? We break it into 4 bits. So, now we will XOR with the K5, and then we have decryption is reverse. So, we have to apply the inverse permutation. We are using a permutation. So, we have to apply the inverse permutation, and then again we have to apply the inverse S box. So, this is inverse S box like this. Okay. So, this is a one round decryption of SPN. So, we have the input, we just do the bitwise XOR with the round keys, then we apply the inverse permutation, and then we apply the inverse S box to go back to the plain text. So, this is the way. So, this inverse should exist, and permutation we have the inverse, and the round keys we also have to generate by the by Bob, which is the receiver. Okay. So, this is the typical SPN network, and so this is the inversion. So, this is a general structure of a stream block cipher, where we have this this round functions, and we have the round keys, we have the mechanism to generate the round keys, that is the key scheduling algorithm, and later on we will discuss the DES, which is another block cipher, and then we talk about AES slowly. Okay, thank you.